conditions. So it is this basically this diagram. I hope I can find it. This is centric. Yeah, it is this diagram over here. Okay, it is this entire diagram over here that you need to know. Okay, so when you do your summary sheet, let me get all of them. Okay. Okay. So these are the diagrams that you need to know, and then you write down like what how to identify which is always critical, and the way to identify which fixed string and it is analyze. Okay, you look at analyze based on moment. Okay, you analyze it based on moment. As you can see, this end we call fixed, and this end over here you call free. So what is fixed? Okay, so if we all of them, we use a standard transformation x, y, and this is rotation about z. So down here, when it's fixed, means what? X motion is equal to 0, or yeah, and y motion is equal to 0. But moment about z is not equal to what? 0. Okay, so this is the condition of fixed. Okay, why moment at z at point B is not equal to 0? Because the structure is not rotating at all unless the applied force is applied at P. Okay, so when we look at free, so free is x is not equal to 0, y is not equal to 0, moment is equal to 0. Okay, so that's how I identify how to identify between fixed and free. So free, x displacement is not equal to 0, y is not equal to 0, but moment is equal to 0. Because if you remove the built-in at B, then the structure will in fact rotate. Then when it's fixed, x is equal to 0, y is equal to 0, moment of z is not equal to, is not equal to 0. Okay. So the next one is what we call pinned. Okay, so we call this as pinned. And this one is also pinned. So when it's pinned, what would we mean? So for this case over here, you will see that x is equal to 0, means it cannot move left and right. But y is not equal to 0, and moment is equal to what? 0. Okay, the true indicator is moment is equal to what? 0. So on their side, it is also known as pin because x is equal to 0, y is also equal to 0, m is also equal to what? 0. Okay. So when we classify things as pin, right? When we classify pin, so when it's pin, what you can see that one of the displacement either in x or y has to be 0. Whereas free, if you look at free, x is not equal to 0, y is not equal to 0. When it's pinned, okay, so the bottom and the top one is pinned, okay, because x is equal to 0 at the top at point A, x equal to 0 at point B. But at point A, y is not equal to what? 0, because it can go up and down. But at point A, y is not equal to 0 because it can go what? Up and down. Whereas at B, y is equal to 0 because it can go. So as long one of them is equal to 0, is pinned. But more important is the moment. Okay. So when moment is equal to 0, it can be either free or pinned. But when moment is not equal to 0, it is always known as what? It is always known as fixed. Okay, right? So let's look at another situation over here. Okay, so over here you can see a situation now that over here x, it cannot move in x direction, so equal to y is not equal to 0. Moment is equal to what? 0, because it can rotate. You can see that this is rotating, right? Whereas at point B, you can see at this end, this is straight. Okay, so down here, x is equal to 0, y is equal to 0. So moment is not equal to what? 0. So that's why this end is known as fixed, right? This end is known as pinned, right? It's so clear cut that whenever a moment is not equal to 0, right? Again, another situation over here. Hey, sorry. Another situation over here, right? Where moment is not equal to 0, we always classify as fixed. And then, and in the last situation, right, last situation over here, you will see that both end are fixed. Now this is where things get interesting. Okay, so this end is fixed. And why is it called fixed at both ends? Okay, why is it called fixed at both ends? Because over here, x, now x is equal to 0, but y is not equal to 0. You can see go up and down. However, moment is equal to what? 0. That's why you call it fixed. Whereas at the other end, x is equal to 0, y is also equal, moment is equal to 0. That's why, or not equal to 0. That's why it's called fixed. So the fixed end, the most important thing is a fixed end. Okay, in the fixed end, the moment has to be equal to what? Not equal to the other one, I got it wrong. I do apologize. This is not equal to 0. Okay. So this is how to identify fixed and what is free, what is fixed, and what is P. Okay, so do not get confused, because I will test you if you can identify them at all. Okay, now sometimes the question is more straightforward. It tell you both ends are pinned. Okay, so that is more straightforward. If it's not given, you have to identify based on moment. And then I just remember what to tell you over here. So I come back is buckling will tend to more likely occur, right, with the lower I, which is second moment of area. Okay, that is always the what? That is always the case. Okay. So this is how I will start writing my summary sheet. You know, we're going through a lot of notes. Okay. So after when we have written our summary sheet, so in writing a summary sheet or when doing a revision, you have to understand the topic. Okay, you don't write summary sheet after the first lecture. You have to do your homework also. Then you write the summary sheet at the same time. Okay, so now I will carry on with homework number 1. Now, anyone has, like, which question do you all want me to do in homework number 1? Like, Eugene, can you do this question? Anyone? If not, I'll pick a question for homework number 1. Anyone? Any preference?
The last one.
The last one. Okay, the last one. Okay, so we'll do question number 6. Okay, we'll do question number 6. Right. So now this is going to be my revision sheet. I'm going to also be my summary sheet. Okay, so I'll show you how to improve your summary sheet. So homework number 1 and question number 6. Okay, so let me get that question first. How y'all find the number of question I gave you? Is it too much, too little, or is about right? Any updates? No comment.
It's fair.
It's not too much, right? 6 question is okay, right?
Yeah, it's good.
Okay. Okay. So I'm looking at this question now. Or we are looking at this question now. So so while doing this question, at the same time, I will also give you my thoughts on my marking scheme. Okay, I also give you my thoughts on my marking scheme, how I will mark also at the same time. Okay. So a rod AB is made of L2 steel with diameter 50 millimeters. Determine the maximum mass at C, and that the rod can support without buckling. Use a factor of safety of 2 for buckling. Okay, so we know that we only are given AB. Okay, and we know AB is a rod, and it has a diameter of what? Of 50 millimeters, so 0.05 meters. Okay, so we have to find the maximum mass. This one they want mass, that's why the answer is in kilogram, and we like to use a factor of safety is equal to 2. So over here we already know, hey, what is factor of safety, right? So we did not write anything. I did not write the formula for factor of safety over here. So this is where you update your help sheet, okay, or your summary sheet. So you write down here factor of safety is equal to P critical over P allowable. Okay, or it can also be P critical or just P. Okay, so you just realize, yeah. So this is what I call updating your formula sheet. I forgot to I forgot about it, and I think this is information that's important. Okay, so now we know. So we are going to use a factor of safety of 2. Okay, so what we also know that length AB, okay, length AB. Or before we go to length AB, we know that this buckling is under or structure or member AB. AB is under centric buckling. Okay, we know that is under centric buckling. Right. So the next thing we look, we are not asked to do anything about AD or AC. Okay. So now we have to look at what formula to use. So there are the two formulas that comes to our mind is we know that we need a formula that's P critical is equal to pi squared, right? EI over L squared. Okay. So we see for ourselves, okay? And I do apologize, I forgot to give your information of Young's modulus. So we know in real life, but what is given is L2 still is given, okay? So for the term test, I will not do that to you, okay? I will usually give you the stress, and I also will give you the Young's modulus and the U strength, okay? So from here, we know that we have E, we need to find I, and we need to know what is our L. L is not just so straightforward, okay? L is not just straightforward. Depend on how it's fixtured, the L value can change, okay? So we know that we have to apply the formula P critical, and then the next thing you have to mark, so what, okay? Ultimately, we want to find P, right? We want to find P. So we know that P critical over P is equal to factor of safety. So we know that P critical is equal to factor of safety multiplied by P, right? So from this expression over here, we know that to find P, right, which is equal to P critical divided by factor of safety. So that is our part of answer already. Now this P over here, okay, is what we call FAB. Okay, FAB, which is the axial load, axial compressive load carried by member AB. Okay. So if you look at this structure like that, we need to know what is going on at point A.